So in the previous two videos, we have discussed about 3 to 8 decoder and 2 to 4 decoder. And again, we have also discussed about one more IC, that is 74138, which is having 3 extra inputs and 8 outputs, and all the outputs are active low. So now we shall come to the application part. So how these type of a 3 to 8 decoders can be used in order to design the higher level decoders. Okay, so as the question specifies, design a 4 is to 16 decoder using 3 to 8 decoder. So we have to make use of two decoders whose size is 3 to 8, and we are supposed to design 4 to 16. Okay, so therefore if you just observe, I have shorted ABC. Actually, there will be a, we need to short A and B as well as C, and one more input will be there, that is considered as D. Okay, that is considered as D here, and that D should be with an inverter. I'll just show. This D should be an inverter. Why? Because if you observe the truth table, so zeros will be for 8. Okay, D will be taking zeros for 8 combination, and D will be taking 1 for next 8 combinations. So therefore we are giving the input in such a way so that whenever D is having zeros, so whenever I'm passing D is equals to 1, here you will be getting 0. So this decoder output is, you can observe till here. So whenever D is taking the value 1, you can observe the output from this decoder truth table. Okay, so from the first decoder, from the first 3 is to 8 decoder, the inputs are what? A, B, C, and here we cannot call this as an actual input. This we will be considering it as an enable signal. Okay, this we will be considering it as an enable signal. Okay, because we already know that 3 inputs means only 3 inputs should be there, that is A, B as well as C, and this is acting as an enable signal, as we have already discussed in the previous types of decoders. So whenever the decoder is provided with zeros, then this decoder will be activated. Whenever the decoder is provided with an active high input, then this will be activated. I mean to say that if the enable signal is 0, then this is activated. If the enable signal is 1, then this is activated. So how we are going to design this 4 is to 16 decoder is, so the first 3 is to 8 decoder will be having an enable signal with an active low, and the next 3 is to 8 decoder is provided with an enable signal whose status is active high. Okay, so therefore whenever my D value is equals to 0, so if you just observe, CBA is taking 0 0 0 in both the cases, and 0 0 1 in both the cases, see here, and 0 1 0 in the both the cases. So therefore we are supposed to short this. Okay, A, B, instead of shorting, what I have done, I have just given the names, that is ABC here also, and here also ABC I have given. Otherwise you can short these lines and you can just mention ABC at one point. Okay, so now as I have already told you, so the first decoder will be enabled if my D signal is 0, and the second decoder will be enabled if my D signal is 1. So here the D is acting as enable signal. Okay, so now, so if my inputs are 0 0 0, so y naught will be 0, and please remember, here also we are discussing with respect to active low outputs. Okay, here I have not shown, but if you just observe the truth table, all the outputs are 1 1 1, right? So therefore y naught is 0 if my ABC are 0 0 0, and next 0 0 for my data 0 0 1, y1 will be 0, and for my data 0 1 0, y2 will be 0, and for my data 0 1 1, y3 will be 0. So likewise it extends. Okay, now, so now y naught till y7 we have to write it with respect to the first decoder. Next, from Y8 to Y15 is with respect to the second decoder. Okay, so here, if the ABC is taking 0, 0, 0, Y8, okay, Y8, this is Y8, so therefore you can observe Y8 is 0 here, okay. Here Y9 is 0 for my data 0, 0, 1, and Y10 is 0 if my data is 0, 1, 0. This is Y8 and this is Y15. Okay, here I have merged both the truth table. So the truth table looks very complex, but the concept is very easy. So here we are designing a 4:16 decoder by making use of two 3:8 decoders, and we are we are observing the outputs as active low outputs. Okay, next, so realization of multiple output functions using the binary decoder. So now, so we shall just consider a simple example and we shall try to understand this particular concept. So in order to explain this concept, I have taken an SOP function, so which is represented in the form of a sigma, where the min terms are M1, M2, M3 as well as M7. So how you are going to represent it by making use of a 3:8 decoder. So that is what we are going to understand now. So obviously there will be three inputs because the length is from 0 to 7, it has been mentioned. If you have a min terms more than 7, then you would have gone for 4:16 decoder. But since the min terms has been stopped by 7, you have to consider only three inputs, that is A, B, C. So now how to, and we shall also consider one of the active low enable signal, and which is represented as En. So we have already discussed about this. So to enable this decoder, you have to give 0 to this decoder. Okay, to activate this decoder, you have to give 0 here. Okay, that is what. Next, the outputs are Y0, Y1, and the outputs are Y0 till Y7. And what are these lines? Okay, so I am extracting one output from Y1 because the min term is 1, and I am also extracting from 2 because the min term is 2, and I'm also extracting from 3 because the min term is 3, and I'm also extracting from 7 because the min term is 7, and finally we have to give it a OR gate because this is an SOP operation or the SOP function where the product terms are ORed together. So therefore, all the product terms are ORed together. I mean to say that all the product terms are added together in order to get the expression that is Y. Okay. So this is how you are going to implement any of the SOP function by making use of the decoder circuit. Next, we shall take another example, that is a POS. So how we are going to implement the POS function by making use of a 3:8 decoder. So it is very simple. Again, we are considering the three inputs, that is ABC. And since we are considering the POS function, that is a product of some function, it is represented with the max terms where you can observe the pi symbol here. Okay, max term 0, max term 2, fourth max term, and sixth max term. Okay, again, this particular function can be implemented by making use of a 3:8 decoder only because the length has been stopped at 6th only. If it is having 12 or 14th number, if it is having 12, okay, after 6, if it is having 12, then you are supposed to use 4:16 decoder. So since we have considered an active low enable signal, you have to provide 0 in order to activate this 3:8 decoder. So now there are 8 outputs, that is Y0, Y1 till Y7. So I am taking the output Y0, I have to take next Y2, next I have to take Y4, next I have to take Y6. Okay, all these things has to be provided to the AND gate. Okay, why we have to provide it to the AND gate now? In the previous case, we have given to OR gate. Now we are providing it for AND gate because this is a POS equation. I mean the POS function. All the max terms has to be ANDed together. Right there, the min terms was ORed. Now the max terms are ANDed together.